Hey guys, this is Miss Reynolds here going over today's math lesson. So today's math lesson is 8.5. Now, I know that some of you guys are going to be confused by that, saying, well, we left off on 7:13. We are jumping ahead a little bit, but that's okay because 8.5 is another line plot lesson, so it's going to tie in great with what you did last week for 7:13. So you are on the correct lesson, and today's lesson is 8.5. So let's go ahead and jump in by starting off and reading this top paragraph here and figuring out what we're being asked to do. So it says, The Right Stuff, a stationery store, sells a variety of different size envelopes for business and personal correspondence. The height and length of the envelopes are given in the tables below. So here's the height and here's the length for both business and personal. All measurements are in inches. Okay, so that's going to be super important. So when it says over here the height is 3.5, it's 3.5 inches. Now, when I'm looking at these tables, I notice that the fractions are all kind of in different sizes and they have a lot of different denominators. But what I do notice is they are all factors of 8. So all of our fractions down here are going to be to the nearest 1/8 inch. So let's scroll down and figure out what we need to be doing for our title, or for our line plot, and as well as what we need to write for the title. Plot the heights of all the business and personal envelopes on the line plot below. So we're just worried about this gray column here that up at the top it says height. So we're just worried about the gray column. So for the title of my line plot, it's going to simply be, let's see how quickly I can write this, envelope heights. Hopefully your handwriting is a little bit better than mine on the computer. So envelope heights is going to be our title. Then down here at the bottom, our label, meaning what each of those X's that we're going to plot is going to represent. It's going to represent the height in inches. Okay, so right now, as I go back up here and I'm looking at what I need to do, I'm noticing again that, and reminding you again, I should say, that these are to the nearest 1/8 inch. So we're going to do the first couple together. I noticed that 3.5 is already on here because that's one of our main markers. So that's great. So I can go ahead and come over here and plot down 3.5. Now, 3 5/8 would be what would come right next after 3.5, because 3.5 is equal to 3 4/8. So what's going to come after 3 4/8? 3 5/8. So I can put an X right here. So I want you to go ahead and fill in the rest of this chart on your own, and then we are going to continue to work on this together in a little bit. So go ahead and pause, and then we'll go back. All right, welcome back. So I'm going to go ahead and fill in the rest of the chart for you, and I hope that you can follow along and fix any mistakes if you made any at all. So we already have our 1 for 3.5. Now when I come over here, I'm going to find that there are 2 more, or 3 in total, for 3 5/8. There is 1 for 3 6/8. There are 2 for 3 7/8. Next, from there on, I have 1 for 4. I'm going to have 1 for 4 1/8. Now, I don't have anything for 4 2/8, so that's okay, so I leave it blank. 4 3/8 has 1. Now, remember, that half is the same as 4 4/8. So 4 4/8, or 4.5, has 1. Next, 4 5/8 does not have any. 4 6/8 has 2. 1, 2. 4 7/8 has 0. 5 has 1 envelope with the height of 5. 5 and 1/8, there are none. 5 and 2/8, or 5 and 1/4, has 1. None for 5 and 3/8. 1 for 5 1/2, or 5 and 4/8. Nothing for 5 and 5 5/8. There is 1 though for 5 and 6/8. Nothing for 5 and 7/8, and then there are 2 envelope heights for 6. So there we go. I'm actually going to fix this one over here for our 5 and 6/8, so it looks more like it's on there. All right, here we go. So that is what our line plot should look like. Now, when I come down here for our questions, it's going to ask you a variety of questions that connect back to this line plot up here. So you need to make sure that your line plot is accurate before you answer these questions. All right, and it tells you the same thing up there. So we're going to do number 1 together. And then I think that you guys are going to be able to figure out the rest on your own. Okay? Now, some of them do start to talk about different things, and you're going to have to do some subtraction in addition, and you guys are great at that by this point. Okay, so for number 1, it says, what is the largest envelope height sold in inches? What is the largest envelope height sold in inches? So you're going to go back to your chart, and if I'm looking for the height sold, I know that the largest is, I'm going to come over here. Let's see if we can write it. My largest is 6 inches. Okay, so you're going to finish the rest of these on your own, referring to the chart that we did over here. Okay, and let's go over our math boxes for the week. Now, for the most part, these are things that you guys have already done and should be fairly comfortable with. Okay, now the first one is talking about measuring. And we know that you're going to use one of those anchor measurements that we talk about, where 90 degrees is a right angle, 180 degrees is a straight line, 360 degrees is a full circle. So it says, how many degrees will Paula need to move the back of the chair to be flat? All right, so maybe Paula's doing some sun tanning or something and wants that back of the chair to be flat. So if I know that a flat line is 180, and I already have 130, I have to figure out how much is going left. So I would need to do a measurement of 180 minus 130 to get my unknown measurement. Okay, because I already have 180. I know that's my whole thing. And part of it's 130, so I'm going to have to do the rest. All right, I'm going to help you guys get set up on number 2 because that's a pretty tricky one. And then you should be able to do the rest on your own because it's, again, adding fractions and subtracting fractions, which we've been doing. So number 2 says the Merman family used 3,955 liters of water in a week. In the Santana family, used 4,263 liters during the same week. On average, how much more water did the Santanas use in one day than the Mermans? So I need to figure out how much each person used in a day, or each family, then I need to subtract. So what we're going to have to do here is we're going to have to divide each of these numbers by 7 first, because this is for the whole week. And I know that there are 7 days in a week. So I'm going to need to do 4,263 divided by 7 first. And then I'm going to subtract that from 3,955 divided by, there we go, 7. And that is going to give me my answer. So you're going to have to do 2 division problems. Then you're going to subtract, and that's going to give me my answer in liters. And then to figure out in milliliters, I'm going to have to make that conversion. And I know that 1 liter equals 1,000 milliliters. So use your zeros trick to help you there. So I hope this lesson helps out, and I'm sure that you guys are going to be line plot pros by the end of 4th grade. Have a great day.